So the first task here is to evaluate the truth of a formula relative to a given valuation. So here we have an example. We have the formula not P and Q. So this is the formula we're going to evaluate. And we have defined a valuation V such that this valuation assigns 0 to P and 1 to Q. This is just an arbitrary stipulation. We could have picked another valuation that assigned different values to P and Q, but this is what we're going to work with. So V is a truth valuation that assigns truth value 0, 1 to the atomic proposition. And in this case, it assigns 0 to P and 1 to Q. So what we want to know now is what is the truth value of the more complex formula not P and Q. This is the task. Okay, what we need to do is to follow the truth table for negation and for conjunction. So according to the truth table for negation, if P has truth value 0, then the negation of P must have truth value 1, and this is what we have here. Now, if not P has truth value 1, and if Q has truth value 1 as well, then the truth value of the conjunction of not P and Q must be 1 as well. This follows from the truth table for conjunction. Now, what is important here, and it's a point worth emphasizing, that order matters. Now, what we've done here in assessing the truth value of the complex formula not P and Q, we have started with the truth value of P and Q, then we have assigned a truth value to not P, and then finally we have assigned a truth value to not P and Q. So this is a process that goes from the more simple to the more complex. And in this process we found out that our formula has truth value 1. Our formula not P and Q relative to the valuation V has truth value 1. We can write this in symbols in the following way. V makes true not P and Q. So we write it this way. So V makes true not P and Q. So this symbol here with the vertical arrow and these two horizontal bars is understood as makes true. So the valuation V that we have picked makes true the formula not P and Q. Now there is one point that I should emphasize, which is that the expression V makes true not P and Q, so this expression is not a formula. So what is a formula is simply not P and Q, and the expression V makes true not P and Q is a statement about the truth value of the formula, is not itself a formula. Let's consider a second example, the formula P and P implies Q implies Q. So this is a much more complex formula, and we are evaluating it relative to our valuation V. So we are assuming that P gets the value 1. So here again, P gets the value 1 and Q gets the value 0. This again is an arbitrary assignment of truth value to our atomic proposition P and Q. We could have picked a different assignments. Now the task is to assess the truth value of our more complex formula right here. So we start from this proposition here, P implies Q. And since we have that P has value 1 and Q has value 0, then we know by the truth table of the implication that the implication must have value 0. Now we have that P has value 1 and this conjunct has value 0, and therefore we should say that the conjunction has value 0. This just follows from the truth value, the truth table for the conjunction. And then finally we have the antecedent here. This is the antecedent of our implication, and this is the consequent of our implication, Q. The consequent has value 0, the antecedent has value 0. So by the truth table for the implication as a whole has value 1. And so we can say that relative to this valuation V, the formula in question is true. And this is what this statement means. Simply that V makes true P and P implies Q implies Q. We can see a couple of more examples here. So this second example here is not P. So supposing that V assigns 0 to P, which means that not P has value 1, and then not P has value 0. Because remember, according to the truth table of the negation, what negation does is simply to invert the truth value. So if P has value 0, then not P has value 1, and not P has value 0 again. So relative to this valuation, we cannot say that the valuation makes not P true. In fact, it makes it false. And so instead of writing this vertical line with these two horizontal lines, we write the vertical line with the two horizontal lines and we cross it. And this simply means that the valuation does not make the formula true. We can see our last example here. P implies Q, or Q implies P. So P implies Q or Q implies P. We should start from the atomic proposition P and Q, and we are supposing that V assigns 0 to P and 1 to Q. So assigns here 1 to Q and 0 to P. Then we start evaluating the more complex proposition P implies Q and Q implies P. So since P is false and Q is true, then the truth value of the implication P implies Q must be true as well. And since Q is true but P is false, then the truth value of the implication Q implies P is false, because remember, there is one case in which the implication is false, namely the case in which the antecedent, in this case Q, is true and the consequent is false. In this case, the consequent is P. So we have that P implies Q is true as truth value 1, and Q implies P is false as truth value 0. Now, since we have that they have one as truth value 1 and the other as truth value 0, the disjunction, the truth table of the disjunction, if you remember, requires that only at least one of the two components, one of the two disjuncts has to be true, and therefore the disjunction as a whole has also truth value 1. And so we can say that the valuation in this case makes true the formula P implies Q or Q implies P.